In the second video of our bonding installment, we will be discussing the specific type of bonding called an ionic bond. So let's get right into it. A specific type of bonding is called an ionic bond. By definition, we're basically saying that an electron has to be transferred, and this will occur between metals and nonmetals. So there's two specific characteristics of an ionic bond: a transfer of electrons, and this happens between metals and nonmetals. The reason is, if you recall when we talked about it from periodic table, is that metals have low ionization energy. Right? Low ionization energy means it's easy to lose electrons. So metals like to lose electrons because it does not take a lot of energy, and it does not take a lot to do so. They willingly give them up. The nonmetals, on the other side of this, they have high electronegativity. And what high electronegativity gives them the ability to do, I shouldn't write high, what I should be writing is high electronegativity means it is easy to gain electrons. And so you have this perfect combination of elements and atoms that want to lose electrons and other elements and atoms that want to gain electrons. And it's basically a match made in heaven. There's a back and forth that is perfect. I don't want them, metals don't want them, nonmetals want them, and this exchange happens. Now the big thing to remember here is that I said they transfer. And transfer basically means it's a permanent situation. So the metals become a positive ion. Sodium is Na, and it has one valence electron. When it creates an ionic bond with a nonmetal, it's going to become Na+, and it no longer has that valence electron. Chlorine, with 7 valence electrons, will turn into a Cl- because it has gained the electron from the sodium. This is how an ionic bond occurs. This is an attraction. Here we go. This is an attraction called a polar attraction. So once this exchange occurs, once this exchange of the sodium giving an electron away to the chlorine occurs, the positive and negatives are then attracted, just like two parts of a magnet, and they stick together, and that's called an ionic bond. If you were taking AP chemistry or higher levels of chemistry, you're really looking for an ionic bond to be classified as a large difference. And a large difference is when they're 1.7 or greater. So in the example of NaCl, we're dealing with an element of sodium with a 0.9 electronegativity. We're dealing with chlorine having a 3.2 electronegativity. And if I found the difference between these two elements, I would be looking at a 2.3 electronegativity difference. In higher levels of chemistry, this is what classifies something as an ionic bond. And it's basically because the electronegativity difference is so strong, the electron gets ripped away, and it holds on dearly to the higher electronegative atom. We will represent these, and I will show you how this transfer occurs using some Lewis dot diagrams. So I've kind of already explained this, but I will do it one last time, or one more time. We write down our original dot diagrams, a sodium atom and a chlorine atom. The exchange that happens is from the lower electronegative metal to the higher electronegative nonmetal, and the electron will basically move its way over like that. The resulting bond becomes Na plus and Cl minus. All right, but we'll try another one that I have not yet explained. So magnesium is a metal with 2 valence electrons. Oxygen is a nonmetal with 6 valence electrons. So again, it's the same idea. The metal will be giving its electrons away to the nonmetal. And this process has to continue until the metal is completely empty and the nonmetal is completely full. So we'll go 1 electron at a time by moving this electron to oxygen. Now, oxygen originally had 6. By adding 1, it would then have 7. It's not good. It's not great because we need to have 8. And we need to have 0 on the magnesium, and there's still 1 left over. So in our heads, we are also going to move a second one over. And by doing so, we've completely emptied the metal of all of its electrons. So magnesium had 2 electrons, and it lost both of them, so leaving it with no valence electrons and a +2 charge. The oxygen gained 2 electrons, filled up its outer shell, and is now a -2 charge. This is the ionic bond between magnesium and oxygen. Things get a little tricky with these other 2 examples, so I'll show you how problems can arise. We will have sodium and sulfur. 1 valence electron and 6 valence electrons. At the start, it's the same process, right? The metal will give its electron to the nonmetal. So there's one good thing and one bad thing that comes out of this. Sodium, the Na, no longer has any valence electrons. The sulfur has 1 more than it did, but it still does not have 8 valence electrons. So the only way to fix this problem, to fix this situation, is to bring another sodium into the equation. By adding a second sodium, we've created a second source of valence electrons that can be transferred from one atom to the other. And to show this final answer, it would look exactly like what you see. It required 2 sodium atoms to become +1. 2 sodium atoms lost an electron. And when 2 sodium atoms lost an electron, 1 sulfur was able to gain 2 valence electrons. And we can write it just like that. And I'll do one last one, and then we'll get ourselves out of here. Magnesium with 2 valence electrons, and iodine with 7. The metal will always lose its electron to the nonmetal. And when it does that, iodine is actually complete. Iodine has 8 valence electrons. The problem that still remains is the magnesium is holding on to 1 valence electron. And this will not fly. All right, we have to get rid of all of the electrons, and we have to gain all of the electrons. And so by adding a second iodine, we can move the extra electron from magnesium out, emptying the whole shell of magnesium. So what happened here? 1 magnesium lost 2 electrons. It became a +2. 2 iodines each gained 1 electron to complete its shell, and in the process became a -1 charge. And that's how ionic bonds and their Lewis dot diagrams work. I hope you enjoyed the video. Stay tuned for the next one.